July 1945. Fusa Airfield, north of Tokyo. A Nakajima Ki. 8-4 fighter roars down the runway, except this one sounds different. Lighter. Hollow. As it climbs into the morning sky, test pilot Lieutenant Yamamoto notices something terrifying. The wooden skin on his right wing is beginning to peel away at 350 miles per hour. This isn't battle damage. This is a brand new aircraft fresh from the factory. Built entirely from wood and glue. 3 months earlier, American bombers had devastated Japan's aluminum supplies. Desperate engineers received orders from Tokyo. Redesign our fastest fighter using trees instead of metal. Build it with carpenters instead of machinists. And do it in 4 months. They succeeded. The key, it even performed well. But when Japanese pilots began losing battles in these wooden wonders, their commanders didn't blame the aircraft. They blamed the men flying them. This is the story of desperation, denial, and institutional betrayal at the highest levels of Japanese military command. By 1943, Japan's war machine faced an existential crisis that military planners had predicted but refused to acknowledge. The island nation possessed virtually no natural aluminum deposits. Before the war, Japan imported aluminum ore from Dutch East Indies, Malaya, and ironically, the United States. When those supply lines severed, first by American embargo in 1940, then by Allied submarine campaigns after Pearl Harbor, Japan's aviation industry confronted a ticking clock. Every Zero fighter, every Betty bomber, every trainer aircraft consumed tons of duralumin, the aluminum alloy that made modern aviation possible. By mid-1943, Japanese factories scraped together whatever they could find. Housewives surrendered pots and pans in patriotic aluminum drives. Engineers melted down damaged aircraft. Workers salvaged metal from crashed planes in the jungles of New Guinea and the Philippines. It wasn't enough. The Japanese aircraft industry reached peak production in September 1944. 28,180 aircraft that year alone. But this achievement came at a devastating cost. Factories had consumed every reserve of aluminum sheeting, every ingot, every scrap. By October 1944, warehouses stood empty. Meanwhile, American B-29 superfortresses began striking Japanese factories. The November 1944 raids on Nakajima's Musashi engine plant near Tokyo destroyed production capacity that could never be recovered. Engineers watched decades of industrial development burn in a single afternoon. Faced with complete collapse, Japan's munitions ministry issued a desperate directive. Develop all-wood combat aircraft. Convert the best fighters in their inventory, the key, 8-4 Hayate, into plywood and pine. Use unskilled labor. Employ women, children, and forced laborers from Korea and China. Build them in caves if necessary. What nobody wanted to admit publicly was that this crisis stemmed not from Allied bombs, but from fundamental miscalculations made years earlier. Japanese military planners had launched a war they couldn't sustain. They'd conquered resource-rich territories but couldn't defend the sea lanes needed to transport those resources home. They'd built a world-class aviation industry without securing the raw materials required to keep it running. When the house of cards collapsed, those same planners needed someone to blame. The easiest targets, the young men strapping themselves into increasingly defective aircraft and dying in droves over the Pacific. This is the untold story of the key. 106, Japan's wooden fighter, and the lie that tried to hide an empire's industrial failure. To understand how Japan arrived at this crisis, we need to rewind to the beginning, when Japanese aviation was built on borrowed dreams and foreign expertise. The American foundations in 1921, something remarkable happened. A delegation of Japanese naval officers arrived at MIT, Stanford, and the California Institute of Technology. These weren't spies. They came openly, with visas approved by the U.S. State Department. For the next decade, America's finest engineering schools trained the men who would design the Zero fighter and Betty bomber. The irony cuts deeper. Throughout the 1930s, Nakajima Aircraft Company purchased production licenses for American engines from Wright Aeronautical Corporation. Mitsubishi bought Curtiss fighter designs. Sumitomo Metals acquired rights to Hamilton Standard propellers. Mitsui and Company, operating from New York City offices, facilitated these transactions without interference. American companies sold Japan the blueprints for its war machine, then watched in shock when those same designs returned painted with rising sun markings. The illusion of self-sufficiency. By 1937, Japanese nationalism demanded the appearance of independence. The military decreed that only Japanese-designed aircraft would be accepted. Foreign engineers were dismissed. Technical missions stopped visiting American factories. But this was the Japanese designers still copied foreign models, now simply purchased as reference specimens rather than licensed designs. The veneer of self-reliance masked fundamental dependencies that would prove fatal. Chief among these, aluminum. The resource trapped Japan's conquest of Southeast Asia in 1941. 4. 2 promised to solve the aluminum problem. Bauxite mines in Java and Malaya could feed Japanese smelters. The co-prosperity sphere would provide what the home islands lacked. Reality crushed this vision within 18 months. American submarines prowled shipping lanes with devastating efficiency. In 1943 alone, submarines sank 1.8 million tons of Japanese merchant shipping. War carriers loaded with bauxite became priority targets. Ships that survived the gauntlet from Java to Japan often discovered their cargo had been contaminated by seawater flooding holds during depth charge attacks. Even successful shipments created problems. Japanese smelters, designed for small-scale production, couldn't process ore fast enough. Electrical power shortages, coal and oil were equally scarce, meant furnaces operated far below capacity. By early 1944, the math became inescapable. Japan's aluminum stockpiles would be depleted by autumn. The false peak September 1944 marked a moment of seeming triumph. Japanese factories delivered 2,572 aircraft that month. Propaganda celebrated this achievement. Workers received medals. Production targets for 1945 projected even higher numbers. Nobody publicized the truth. Those aircraft consumed the last reserves of aluminum sheet metal in Japan's warehouses. October's production fell to 1,891 aircraft. November, 1,517. December, 1,169. The collapse had begun. The engineering response, on September 8, 1943, a full year before the crisis peaked, someone at Japanese Army Air Force headquarters had the foresight to issue a quiet directive. Instructions went to Tachikawa Aircraft Company, begin studying how to redesign the Nakajima Ki-8 for Hayate using primarily wooden construction. The 8-4 represented Japan's finest fighter development. Fast, maneuverable, well-armed with two 20mm cannon and two 12.7mm machine guns. In the hands of skilled pilots, it could match any Allied fighter. American pilots who encountered the Frank, the Allied codename, learned quickly to respect its capabilities. Tachikawa received complete blueprints for this all-metal aircraft and an impossible assignment: recreate it using wood. Engineers faced extraordinary challenges. Metal aircraft relied on load-bearing aluminum structures. Wings consisted of internal spars and ribs covered with stressed aluminum skin that shared structural loads. You couldn't simply swap wood for metal. The entire airframe required redesign. Weight distribution would shift. Aerodynamics would change. Control surfaces needed recalculation. And critically, wooden aircraft absorbed moisture, expanding and warping, temperature fluctuations in combat, freezing at altitude, tropical heat at sea level, would torture wood and glue joints. For 18 months, Tachikawa's engineers worked in secret. They tested different wood species: Japanese cypress for fuselage frames, plywood sandwiches with balsa cores for wing surfaces, multiple adhesive formulations. They borrowed techniques from the British Mosquito bomber, which proved wood could work for combat aircraft. But the Mosquito had years of development and operated in different conditions. The project received designation Key 106. Few people outside Tachikawa's design bureau knew it existed. That changed in November 1944. Black November, November 24, 1944, 111 B-29 superfortresses appeared over Tokyo in broad daylight. Their target, Nakajima's Musashi plant, Japan's largest aircraft engine factory. The facility sprawled across millions of square feet, producing the troublesome Nakajima Ha 4-5 home air engines that powered Ki-84s. This single complex manufactured 30% of Japan's aircraft engine output. The superfortresses dropped 277 tons of incendiary bombs. Firestorms engulfed production halls. Temperatures reached 2,000 degrees. Precision machinery, lathes, mills, heat-treating furnaces warped beyond repair. Die-casting equipment cracked. Jigs that held engine components during assembly turned to scrap. More devastating than physical destruction was the psychological impact. If American bombers could strike Tokyo in daylight with near impunity, nowhere in Japan was safe. Panic spread through the aircraft industry. The dispersal disaster within days, the Japanese government issued emergency orders, disperse aircraft production into tunnels, caves, and camouflaged facilities, move machine tools into mountains, scatter assembly lines across dozens of small workshops, go underground if necessary. The directive was understandable but catastrophic. Moving a factory isn't like precision machinery, requires careful alignment. Temperature and humidity control matter for metalworking. Supply chains connecting thousands of parts suppliers to final assembly plants depend on infrastructure, roads, rail lines, electrical grids. Japan attempted to relocate its entire aircraft industry while under bombardment, without adequate transportation, with chronic fuel shortages, and with increasingly untrained workers. Production collapsed faster than bombs alone would have achieved. At this moment of maximum crisis, the key 106 wooden fighter transformed from experimental backup plan to desperate necessity. On February 1945, the Munitions Ministry gave Tachikawa approval to build 3 prototypes for flight testing. The clock was ticking. Japan had, perhaps 6 months before aluminum supplies ran out completely, the wooden fighter had to work. It had to prove that Japan could keep fighting even without metal. And when those aircraft took to the skies, they would reveal something far more dangerous than material shortages: the willingness of commanders to sacrifice pilots rather than admit their own failures. Spring 1945, Tachikawa's workshops hummed with unfamiliar sounds. Instead of metal-cutting lathes and riveting hammers, workers operated bandsaws and sanders. The sharp smell of acetone-based adhesives replaced cutting oil. Carpenters who'd spent careers building houses now shaped fighter aircraft components. The transformation revealed just how far Japan had fallen. Project engineer Nakamura Takeshi supervised construction of the first Ki 106 prototype. In a 1962 interview, decades after the war, he described the challenges with brutal honesty. "We were attempting to build a race car using techniques for constructing furniture. The requirements didn't align." Material selection: Japanese cypress formed the primary structural material. Engineers chose it for strength-to-weight characteristics superior to most hardwoods. The fuselage skeleton consisted of cypress longerons, long structural beams running nose to tail, with cypress ribs creating the characteristic cross-section. For wing construction, designers employed plywood sandwiches, 2 thin sheets bonded to a balsa wood core. This technique borrowed directly from British mosquito construction. The resulting panel weighed roughly 60% of equivalent aluminum sheet while maintaining acceptable strength. But acceptable was relative. Metal fatigue happens gradually. Wood fails catastrophically. An aluminum wing spar develops microscopic cracks that grow slowly, often detected during inspections. A wooden spar subjected to combat maneuvering loads can splinter without warning. Test pilots would be gambling on mathematics and prayer. The adhesive gamble nothing worried engineers more than bonding methods. Japanese adhesive technology lagged years behind Western equivalents. The primary glue available, a casein-based formula derived from milk protein, worked adequately in controlled conditions. In field environments, nobody knew. Casein glue weakened when exposed to moisture. Tropical humidity could compromise bonds within weeks. Temperature cycling caused differential expansion between wood and adhesive, creating shear forces at joint interfaces. Nakamura's team tested alternatives: synthetic resins, phenol formaldehyde compositions, even experimental rubber-based adhesives. Each had drawbacks. Synthetic resins required high-temperature curing, difficult to achieve in dispersed workshops lacking industrial ovens. Rubber adhesives added significant weight. They settled on phenolic resin for critical structural joints, with casein glue for secondary attachments. Every joint received inspection marks, painted lines across bonded seams so supervisors could detect slippage. It was a system designed for distrust. Labor force composition. By March 1945, Japan's skilled machinists were either in uniform, working at higher priority facilities, or dead. Tachikawa's Ki 106 project relied on whoever remained. Personnel records show the workforce demographics: 40% women, many widows of fallen soldiers; 25% men over age 50 or medically unfit for military service; 20% Korean conscript laborers; 15% school children aged 1416 mobilized under student mobilization law. These workers received minimal training, sometimes only days. Before handling complex aircraft assembly, quality control became a constant battle. One supervisor noted in daily reports, found incorrect grain orientation in 3 wing ribs during inspection. Workers don't understand wood strength varies with grain direction. Rejected components, ordered replacements. Such discoveries delayed schedules repeatedly. Building the first prototype, the first Kaie 106, took shape slowly through March and April 1945. Workers assembled the wooden fuselage frame, installing the Nakajima Ha-45 engine, still metal because no alternative existed for power plants. The landing gear presented immediate problems. Designed for metal mounting points, the hydraulic struts attached to reinforced aluminum brackets. Wooden substitutes couldn't handle the stress. Engineers fabricated composite mounting points. Hardwood reinforced with steel plates scavenged from damaged aircraft. Weight became an obsession. Every component went on scales. The wooden airframe came in 220 pounds heavier than equivalent metal construction, opposite of initial predictions. Additional structural reinforcement for areas that flexed during ground testing added more weight. By late April, the first prototype's empty weight exceeded the metal cube 84 by nearly 300 pounds. This had serious implications. Weight meant reduced performance, lower top speed, decreased climb rate, shorter range. The wooden fighter would enter combat already handicapped against Allied opponents, engine troubles. While Tachikawa struggled with airframes, a larger crisis was unfolding. The Nakajima Ha-45 engines themselves were failing at catastrophic rates. This deserves explanation because the engine situation exemplified everything wrong with Japanese production by 1945. The Ha-45 Homer was an 1.8-cylinder, twin-row radial engine rated at 1,990 horsepower. When it worked, Nakajima had designed it as a compact, powerful engine to compete with American. The tight packaging created cooling challenges and required precise manufacturing tolerances. As Japan's situation deteriorated, those tolerances became impossible to maintain. Critical alloying elements, cobalt, chromium, nickel, molybdenum, were running out. These metals made the special steels required for high-stress engine components. Cylinder heads needed to withstand extreme temperatures. Crankshafts endured tremendous rotational forces. Bearings operated under crushing loads at high speeds. Engineers substituted whatever they could find. Inferior steel alloys, experimental compositions, anything to keep production moving. The results were predictable. Engines delivered to squadrons in early 1945 suffered fuel pump failures, cylinder head cracking, bearing seizures, and catastrophic internal component failures. Pilots reported loss of oil pressure mid-flight, connecting rods broke, punching holes through crankcase walls. Propeller governors malfunctioned, causing overspeeding that tore engines apart. Maintenance crews worked miracles keeping aircraft flyable. One mechanic's diary, recovered after the war, recorded the grim routine. Changed engine on aircraft 47. Third replacement this month. Previous engine lasted only 12 flight hours before seizing. New engine shows metal particles in oil after ground test. Installed anyway, no alternatives available. Even engines that functioned developed problems quickly. The specified overhaul interval was 150 hours. By 1945, engines were pulled for overhaul after 3050 hours. Many never completed a full overhaul cycle before parts shortages made them unrepairable. So the Kito 106 faced a dual crisis. Wooden airframes of uncertain reliability mated to engines failing at rates that would have been unacceptable in peacetime. First flight, July 1945. The first Ki 106 prototype was ready for testing. Test pilot Lieutenant Yamamoto received the honor or burden of the maiden flight. His log entry that morning captured the tension. Aircraft appearance satisfactory. Concerns about structural integrity remain. Will conduct conservative flight profile for initial test. The engine started normally. Yamamoto taxied carefully, testing control response. Everything felt acceptable. He advanced throttle for takeoff roll. The Ki 106 accelerated down Fusa Airfield's runway and lifted into the air. For 10 minutes, Yamamoto conducted gentle maneuvers. Shallow banks, gradual climbs. The aircraft handled reasonably well. somewhat heavier on controls than metal Ki-84s, but flyable. Then, during a climbing right turn at 6,000 feet, he heard a sound that stopped his heart, a sharp crack, followed by rushing wind. The wooden skin on his right wing was peeling away. Yamamoto had seconds to react. He rolled wings level immediately, reducing angle of attack to decrease aerodynamic loads on the damaged wing. The peeling skin fluttered violently. A 3-foot section curled back like a broken fingernail. Descending carefully, maintaining symmetrical flight, he brought the Ki-106 back to Fusa. The landing was smooth, the structure held. Ground inspection revealed the failure mode. Adhesive bond separation between plywood skin and wooden rib structure. The specific failure occurred at a location experiencing high air pressure during the turn. Engineers had underestimated local stress concentrations. Nakamura's team strengthened bonding at similar locations on remaining prototypes. They added more frequent inspection requirements. They reduced maximum G-load limits from 7.0 to 5.5. Meaning the wooden fighter couldn't maneuver as aggressively as metal equivalents without risking structural failure. But testing continued. Performance evaluations through July and into early August 1945. Test pilots flew the Ki-106 prototypes through increasingly aggressive profiles. They measured maximum speed, 385 miles per hour at 21,325 feet, about 15 miles per hour slower than metal Ki-84s. Climb performance disappointed. The wooden fighter required 7.85 minutes to reach 16,405 feet versus 6.5 minutes for metal versions. Range dropped to approximately 310 miles versus 497 miles for standard Ki-84s. Maneuverability proved acceptable but not exceptional. The wooden fighter couldn't quite match the metal version's turn radius or roll rate. In every performance metric, the Ki-106 was inferior. Yet remarkably, it flew. The concept worked. Barely. Given Japan's desperate circumstances, barely might have been enough. Engineers calculated that dispersed workshops could produce wooden fighters at roughly 70% the rate of metal aircraft. Critically, production could utilize semi-skilled labor, avoiding the machinist shortage crippling engine plants. Projections suggested that by October 1945, monthly Ki-106 production could reach 150 aircraft. By December, perhaps 300. If the war continued into 1946, wooden fighters might have filled Japanese squadrons, but something more insidious was happening simultaneously. The systematic failure of aircraft across the entire inventory and the refusal of military leadership to acknowledge responsibility. The maintenance collapse by mid-1945, Japanese aviation faced a crisis extending far beyond material shortages. At Clark Field in the Philippines, captured in January 1945, American intelligence officers discovered more than 500 Japanese aircraft abandoned in varying states of disrepair. Initial assessments suggested battle damage, but closer inspection revealed something stranger. Aircraft with minor, easily fixable problems sat grounded. One fighter lacked only a carburetor, but nearby aircraft with destroyed engines still had intact carburetors. Nobody had organized salvage operations to cannibalize parts. Tools were buried in random locations with no inventory records. Engine components lay scattered in rice paddies. Maintenance facilities had devolved into chaos. Similar scenes repeated at captured bases across the Pacific. At Rabaul, mechanics reported that of 100 aircraft nominally assigned to the base, typically only 30 could fly on any given day. The others awaited parts that never arrived, repairs that couldn't be completed, or simply sat because mechanics lacked expertise to diagnose problems. The quality control disaster new aircraft arriving from factories often couldn't fly immediately. Factory quality control had deteriorated so badly that field mechanics had to correct defects before operational use. Landing gear systems suffered chronic hydraulic failures. Investigation revealed improper heat treatment of steel components, or absence of heat treatment entirely. Gear legs collapsed during normal landings, destroying aircraft that had never faced enemy fire. Fuel systems leaked. Electrical systems shorted, control cables were installed with incorrect tension, propellers weren't balanced properly, causing destructive vibrations. An index of this disaster, in 1942 and 1943, spare landing gear orders represented 40% of total landing gear production. By 1945, that figure reached 85%, meaning most landing gears lasted only a single installation before failure. The U.S. Strategic Bombing Survey conducted after Japan's surrender, concluded, of aircraft lost during 1944-45, approximately 40% resulted from non-combat causes, accidents during takeoff and landing, mechanical failures, and operational mishaps. Nearly half of Japan's aircraft losses came from their own production failures. The pilot training catastrophe. While aircraft deteriorated, pilot quality plummeted simultaneously. Before the war, Japanese naval aviators underwent rigorous training lasting 2 to 3 years. Army pilots trained for 18 months minimum. These programs produced superb aviators, the men who executed Pearl Harbor and conquered Southeast Asia. Combat attrition devastated those experienced ranks. By 1943, Japan had lost approximately 10,000 trained pilots. Replacement training couldn't match losses. Then came the fuel shortage. In 1943, trainee pilots logged an average of 200 flight hours before operational assignment, already reduced from pre-war standards of 400-plus hours. By early 1944, fuel scarcity forced further cuts. New pilots completed training with 100 hours. By late 1944, 70 hours. Spring 1945, 40 hours total flight time before combat assignment. For context, American carrier pilots in 1945 averaged 600 training hours before combat health. The consequences were predictable and tragic. The blame game begins as Japan's air forces suffered mounting defeats. Military leadership confronted uncomfortable questions. Why were key A-4 fighters supposedly matching American performance, losing engagements? Why did operational readiness rates remain below 50%? Why did pilots report aircraft problems constantly? The truthful answers indicted the entire system: industrial collapse, material substitution failures, quality control breakdown, inadequate training, and, fundamentally, the decision to launch a war Japan couldn't sustain. But truth held little appeal for commanders facing disgrace. In staff meetings throughout mid-1945, a different narrative emerged. The aircraft were fine. Pilots simply lacked fighting spirit. This claim was absurd on its face. Japanese pilots were demonstrating desperate courage in kamikaze attacks, but it served a purpose. It redirected blame downward, away from generals and admirals who'd made catastrophic strategic decisions. Reports began appearing in pilot evaluation documents, in squadron records, in communications to Tokyo. A pattern of accusations: pilot failed to press attack aggressively, mechanical problems reported excessively, suggesting poor morale. Unit performance indicates inadequate fighting spirit. These evaluations had consequences. Families of dead pilots received shame alongside grief. Survivors faced accusations of cowardice when their aircraft malfunctioned. The institutional betrayal was nearly complete. Underscore, 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 underscore. Chapter 3: The Poison of Denial. 950 words, 6 minutes. The morning of August 6, 1945. At Japanese Army Air Force headquarters in Tokyo, staff officers received preliminary information about Hiroshima. A single American aircraft had destroyed much of the city. Initial estimates suggested 60,000 casualties. 3 days later, Nagasaki, another city obliterated by a single bomb. On August 15th, Emperor Hirohito's recorded voice announced surrender. The war ended before the key. 3 prototypes remained at Fusa Airfield. Experimental evidence of desperation that never fully manifested. But the story doesn't end there. What happened next reveals how institutions protect themselves, even in defeat. The American investigation: within weeks of surrender, U.S. strategic bombing survey teams descended on Japanese aircraft facilities. Their mission: document production methods, assess bomb damage effectiveness, and evaluate Japanese aviation capabilities. These investigators discovered overwhelming evidence of systemic failure. At the Nakajima Musashi plant, survey teams catalogued destruction alongside surviving records. Production logs showed engine rejection rates climbed from 12% in 1943 to 43% by mid-1945, meaning nearly half of engines coming off assembly lines failed acceptance testing. At dispersed workshops in mountains north of Tokyo, Investigators found aircraft components manufactured to wildly varying standards. Wing sections from different suppliers didn't fit together. Dimensional tolerances varied by inches, not fractions of inches. At Clark Field, survey teams documented the chaos American forces had discovered. Hundreds of aircraft abandoned not for lack of aluminum but lack of basic maintenance capabilities. The official USSBS report, published in May 1947, stated bluntly, Japanese aircraft production was hampered by material shortages, but equally by poor quality control, inadequate logistics, lack of cooperation between services, and absence of standardization. The interrogation survey teams interrogated Japanese aviation leaders, engineers, factory managers, military officers. Many spoke with surprising candor. General Endo Saburo, chief of the Air Ordnance Bureau, admitted, "We pushed for production peaks without regard for sustainability. After mid-1944, the machinery was worn out, workers were exhausted, supplies were depleted. We borrowed against the future with no plan for repayment." Nakamura Takeda, 106 project engineer, confessed, "The wooden fighter program was technically feasible, but operationally unrealistic. We needed another year of development. We needed standardized construction procedures. We needed trained. We had none of these things." Factory managers described impossible pressures: increase production while dispersing facilities, maintain quality while losing skilled workers, meet schedules while lacking materials. But when interrogators asked about pilot evaluations, about claims that aviators lacked fighting spirit, responses changed. Suddenly, memories became vague. Documents had been destroyed. Responsibility lay elsewhere. Institutional memory. Here's what we know from surviving records. Between January and August 1945, at least 374 Japanese pilots died in aircraft accidents. Not combat losses, but crashes during routine operations. Many of these accidents involved mechanical failures, engine seizures, landing gear collapses, structural failures. In evaluation reports for these deceased pilots, superior officers frequently noted lack of vigilance, inadequate attention to procedures, or insufficient combat spirit. These evaluations affected posthumous honors and family benefits. Consider Lieutenant Nakano Shinji, killed May 14, 1945, when his Kaie 84's engine failed during patrol near Osaka. He attempted an emergency landing. The aircraft's landing gear collapsed on touchdown and the fighter cartwheel, killing him instantly. His squadron commander's report stated, Laerte, Nakano demonstrated poor judgment in aircraft handling during emergency. Investigation suggests inadequate attention to engine monitoring. Investigators later determined the engine suffered bearing failure due to metallurgical defects, a manufacturing problem affecting that entire production batch. No correction appeared in Lieutenant Kennedy, Nakano's record. The pattern, this wasn't isolated incident. Pattern analysis of 1945 accident reports reveals systematic bias. When aircraft suffered mechanical failure resulting in pilot death, evaluations blamed pilot error in 67% of cases. When mechanical failure was irrefutable, engine literally exploding in flight, wings separating, etc., evaluations blamed inadequate maintenance in 51% of cases. Rarely, almost never, did official reports state clearly the aircraft was defective due to production failures, and this death represents system breakdown rather than individual failure. Why? Because institutional self-preservation demanded it. Admitting systemic failure meant admitting the war was unwinnable from the start. It meant acknowledging that Japan's industrial base couldn't sustain modern warfare. It meant confronting the reality that military leadership had sacrificed thousands of lives to delay inevitable defeat. Easier to blame pilots, easier to cite lack of fighting spirit, easier to preserve the honor of the institution by sacrificing the honor of the dead. Post-war silence. After occupation ended in 1952, Japanese society largely avoided discussing these uncomfortable details. Veterans groups focused on shared suffering and sacrifice. Government officials emphasized rebuilding rather than examining wartime failures. The narrative of noble defeat served national reconciliation better than honest accounting of systematic betrayal. Some pilots spoke privately, years later. One veteran interviewed in the 1970s remembered, "We knew the aircraft were failing. Everyone knew, but you couldn't say it. If you questioned the equipment, you questioned the leadership. That was unacceptable. So we flew, and our friends died, and we remained silent." The K-106 itself faded into historical footnotes. The 3 prototypes were scrapped. Design documents survived in archives, studied occasionally by aviation historians fascinated by unusual aircraft. But the larger story, the story of institutional failure and scapegoating, remained largely untold for decades. Until American researchers, combing through captured documents and conducting interviews in the 1960s to 70s, began piecing together what really happened. Let's talk about something that makes this story even more infuriating. They knew. Engineers knew the aluminum shortage was coming. They'd known for years. In 1938, 3 years before Pearl Harbor, Japanese industrial planners conducted resource assessments for potential extended conflict. Their conclusion: Japan possessed reserves sufficient for approximately 1824 months of intensive aircraft production, assuming successful conquest of Southeast Asian resource zones and maintenance of sea lanes. Both assumptions proved optimistic. The report circulated through military planning departments. It was read, acknowledged, and fundamentally ignored. Why? Because accepting its implications meant accepting that the war they planned could. Okano Shigechi, director of aviation materials research at the Munitions Ministry, testified to American investigators after the war. His statement deserves full quotation. In early 1943, my department submitted detailed projections showing aluminum supplies would be depleted by autumn 1944. We recommended immediate transition to aluminum conservation measures, development of substitute materials, and reduction of production targets to sustainable levels. The response from military leadership was silence. 6 months later, we submitted updated projections with more severe warnings. Again, silence. It became clear that information contradicting optimistic production plans was unwelcome. Dr. Okano's team developed the technical specifications used for the Ki 106 program. Their research proved wooden aircraft construction was feasible, but their reports consistently emphasized it was inferior and required extensive development time. Nobody wanted to hear it. The production paradox. Here's the insane part. Japan achieved peak aircraft production in September 1944 after the material crisis was already critical. How? By consuming every reserve, every stockpile, every scrap of aluminum in the pipeline. Factory managers received directives: meet production targets regardless of future sustainability. One production supervisor described the mentality: we were told to worry about this month's numbers, not next year's capacity. When I raised concerns about depleting stockpiles, I was told that battlefield victories would resolve material problems. When I asked how victories would conjure aluminum that didn't exist, I was reassigned. This myopic focus on immediate production numbers guaranteed long-term collapse. Imagine draining your bank account to show strong quarterly spending, then being surprised when you're bankrupt 6 months later. That's essentially what Japan did industrially. The Design Office Rebellion. Some engineers tried to force the issue. At Tachikawa, the Ki 106 design team submitted proposals in late 1943 for an all-wood fighter built from scratch rather than adapted from metal designs. Their argument: starting fresh would produce a better aircraft, avoiding compromises required when converting existing types. The proposal went nowhere. Why? Time. Army Air Force staff insisted modifications of existing designs could be rushed into production faster than clean sheet developments. They prioritized speed over quality, consistently choosing short-term solutions that created long-term problems. At Kawasaki, engineers proposed a radical steel aircraft using stamped panels rather than aluminum sheet. Steel was more available, and stamping required less skilled labor than traditional fabrication methods. This proposal also was rejected. Deemed too experimental when reliable designs already existed, the pattern repeated across the industry. Pragmatic engineering solutions rejected in favor of optimistic assumptions that problems would somehow resolve themselves. The quality control reports perhaps most damning. Quality control inspectors documented the deterioration in real time and were told to keep quiet. Inspection reports from 94445 reveal escalating problems. January 1944. Engine rejection rate 15% due to improper heat treatment. April 1944. Landing gear failures increasing. Metallurgical analysis shows inferior steel alloys. July 1944. Propeller balance problems widespread. Skilled balancing technicians all drafted. October 1944. Fuel system leaks common. Gasket material specifications not being followed. January 1945. Control surface attachment points failing. Riveting procedures compromised by untrained workers. These reports went to production supervisors, factory managers, and military oversight officers. What happened? In most cases, nothing. Inspectors received pressure to pass defective components. One inspector recalled, "I rejected an engine with obvious casting flaws." My supervisor overruled the rejection, stating that operational units would handle problems in the field. When I protested, I was threatened with reassignment to infantry duty in China. Quality standards became suggestions rather than requirements. The maintenance manual problem. Even when aircraft reached operational units in acceptable condition, keeping them flying proved impossible. Standard operating procedure required detailed maintenance manuals for each aircraft type. These manuals specified inspection intervals, parts replacement schedules, and troubleshooting procedures. As Japanese industry dispersed, technical writing staff scattered. Manual updates ceased. Mechanics worked with outdated documentation that didn't reflect modifications made during production. One mechanic kept a diary, discovered post-war, documenting daily frustrations. May 3, 1945, received key 8-4 with modified fuel pump. Number documentation provided. Spent 6 hours determining installation differences from standard model. Lost a day's operational availability because nobody told us about changes. Multiply that scenario across hundreds of bases and thousands of aircraft, the cumulative loss of operational readiness was staggering and entirely predictable. The unspoken truth by early 1945, many Japanese aviation professionals privately acknowledged defeat was inevitable. But military culture, rooted in concepts of honor, obedience, and hierarchical deference, made open discussion impossible. Junior officers didn't contradict senior commanders. Enlisted personnel didn't question officers. Civilians serving military contracts didn't challenge military requirements. This culture of silence transformed engineering problems into moral failings. When aircraft failed, blame descended the hierarchy. Commanders blamed unit officers blamed maintenance crews blamed pilots. The people actually responsible, strategic planners who launched unsustainable war, procurement officers who ignored engineering warnings, commanders who prioritized appearances over reality, escaped accountability. Until the bombs fell, the empire collapsed, and the lies could no longer be maintained. Let's put faces to these numbers. Second Lieutenant Tanaka Hideki graduated from Army Air Force Flight School on March 15, 1945. Age, 19. Total flight hours, 47. He'd wanted to be a pilot since childhood, watching civilian aircraft land at Haneda Airfield near his Tokyo home. In 1942, at age 16, he enrolled in youth pilot training program. Smart, dedicated, passionate about flying. By the time he completed training, Japan was collapsing. His instructors, many recovering from wounds, emphasized aggressive spirit over technical skill because fuel shortages limited training flights. Tanaka received assignment to the 47th Sentai Regiment, defending the home islands against B-29 raids. His aircraft, a Nakajima Ki, 8-4 Hayate. His diary, preserved by his sister and later donated to the Yasukuni Shrine Archive, provides heartbreaking insight. March 20th. First time seeing my assigned aircraft. It appears well maintained, though mechanics tell me the engine has already been replaced twice. They warn me to monitor oil pressure constantly. I'm nervous but determined to serve honorably. March 25th. First combat patrol. Sighted B-29 formation, but engine trouble forced me to break off. Oil pressure dropped rapidly. Made emergency landing at auxiliary field. Mechanics found internal engine problems. Said it's common with recent production runs. Felt ashamed returning without engaging the enemy. April 2nd. Squadron commander spoke to me about yesterday's aborted mission. His words, "Technical problems are often excuses. The Emperor expects total commitment." I tried to explain the engine literally wouldn't run, but further explanation seemed disrespectful. We'll try harder. April 8. Another emergency landing. This time hydraulic failure caused landing gear collapse. Aircraft damaged, but I am unhurt. Commander called it pilot F. I didn't argue. Perhaps he's right. Perhaps I lack proper fighting. Lieutenant Tanaka died on April 14, 1945. His squadron intercepted a B-29 formation over Nagoya. During climbing attack, his engine seized. Catastrophic bearing failure. Without power at 18,000 feet, he attempted to glide toward friendly territory. He nearly made it. The key, 884, stalled while turning for final approach to emergency field. It spun into the ground at high speed. Tanaka died instantly. His commander's official report stated, Letty Tanaka demonstrated insufficient mastery of emergency procedures. His death represents a failure to maintain composure under pressure. Post-war investigation of the engine revealed it should never have been installed. Metallurgical defects were obvious upon disassembly. The engine had been rejected by initial quality control, then subsequently approved by supervisors, overruling inspectors' decisions. The phrase insufficient mastery would follow Tanaka's name in official records forever. The Mechanic's Perspective Staff Sergeant Yoshida Kenji served as engine mechanic with the 22nd Sentai in central Japan. His account, recorded during a 1979 oral history project, provides the ground crew perspective. By spring 1945, we couldn't keep aircraft flyable. Not for lack of skill. We worked 8-hour days, but because we lacked parts and the aircraft themselves were defective. We'd test them and find excessive vibration, poor compression, oil leaks. We were told pilots would make do. I watched pilots fly aircraft I knew were dangerous. I'd tell them, watch your oil pressure, or don't pull hard G-forces, the airframe is suspect. They'd nod, thank me, and take off anyway. When they didn't come back, officers blamed them. Never the aircraft, never the system. I kept a private list. Pilots I'd warned about specific problems who died from those exact problems. 23 names before war's end. After surrender, I burned the list. What good would it do? Everyone wanted to forget. The manufacturer's Defense Nakajima Aircraft Company's chief engineer Iwata Taro testified to U.S. investigators with notable defensiveness. People criticize our quality, but they don't understand the impossible situation. We received orders to double production while losing skilled workers to military draft. We faced material shortages requiring constant substitutions. Allied bombing destroyed our facilities. What were we supposed to do? Refuse production targets set by the military? That was unthinkable. Yes, quality suffered. Yes, engines failed. But we did our best under conditions no peacetime engineer can imagine. Blaming us for problems caused by the war itself is unfair. There's truth in this defense. Individual engineers and workers genuinely did face impossible situations. But it misses the point. The question isn't whether Nakajima's engineers worked hard. They did. The question is why systemic failures that everyone recognized continued without correction. Why quality inspectors who rejected defective engines were overruled. Why concerns raised by technical experts were dismissed. The answer, because the entire system prioritized appearance of capability over actual capability. The statistical horror between January and August 1945, Japanese Army and Navy Air Forces lost approximately 8,200 aircraft, 3,100 to 38%, destroyed in combat, 2,450 destroyed on ground by bombing, 2,650, 32%, lost to operational accidents, mechanical failures, and non-combat causes. That final category, over 2,600 aircraft lost to avoidable failures. Each loss represented not just material waste, but human tragedy. Pilots who survived training, who mastered basic flying skills despite fuel shortages and abbreviated instruction, dying because propeller governors malfunctioned or landing gears collapsed or engines seized. Some died spectacularly, aircraft disintegrating mid-flight, wings failing during combat maneuvers. Some died mundanely. Gear collapses during routine landings, engine failures during patrol flights, control system failures during training missions. All died unnecessarily. Victims of a system that refused to acknowledge its own failures, the aftermath. After surrender, most surviving pilots returned to civilian life quickly. Many never spoke of their experiences. Some, interviewed decades later, expressed lasting bitterness, not toward enemies they fought, but toward the system that betrayed them. One veteran, anonymous interview in 1985, I don't blame Americans for doing their jobs. I blame our leadership for sending us to fight in aircraft we all knew were failing, then calling us cowards when we died. The wooden key, 106, became a footnote. 3 experimental prototypes quickly scrapped, barely remembered even by aviation enthusiasts. But it symbolizes something larger. The moment when Japan's military-industrial complex confronted the ultimate consequences of its own delusions and chose to sacrifice the young rather than admit failure. In 1947, U.S. Strategic Bombing Survey published its comprehensive report on the Japanese aircraft industry. The document ran 155 pages, packed with statistical analysis, factory reports, and technical evaluations. It concluded that Allied bombing reduced Japanese production by approximately 43% between December 1944 and July 1945. But buried on page 94, a single paragraph deserves quoting. While direct air attacks and subsequent industrial dispersal severely reduced Japanese aircraft production, internal factors contributed equally to the collapse. Inadequate quality control, material substitution without proper engineering validation, absence of spare parts logistics, and insufficient pilot training combined to create an aircraft force that was operationally ineffective regardless of nominal production numbers. Number 10. Translation. Even without American bombs, Japanese aviation was dying from self-inflicted wounds. This conclusion challenged post-war narratives on both sides. The Japanese narrative in post-war Japan, discussion of wartime failures evolved through distinct phases. 1945, 1952, occupation era, silence. Most Japanese focused on survival and rebuilding. Few wanted to revisit painful recent history. 1950s to 1960s. Victimization narrative emerges. Focus on Japanese suffering. Atomic bombs, fire bombings, post-war hardship. Military failures attributed primarily to American material superiority. 1970s to 80s. Nuanced examination begins. Veterans aging and willing to speak more openly. Historians access archived documents. First comprehensive analyses appear. 1990 present, growing acknowledgement of systemic problems, though complete honesty remains elusive. Throughout, a consistent pattern. Institutional failures easier to blame on external factors, American resources, Allied technology, than internal dysfunction. The key 106 story fits this pattern. Ask Japanese aviation historians about it today. Most emphasize desperate innovation in face of American bombing rather than symptom of unsustainable war planning. The American narrative. American accounts have their own blind spots. Post-war analysis emphasized Allied bombing effectiveness, understandably, since demonstrating air power's strategic value mattered for future military planning and budget allocations. But this emphasis sometimes overstated bombing impact while understating how Japan was collapsing internally. Consider. U.S. Strategic Bombing Survey concluded attacks on Japanese aircraft industry reduced production by 43%. Significant, but it means 57% of production loss came from other factors, primarily the material and organizational failures we've discussed. American accounts celebrated technological superiority, which was real, while sometimes missing that Japan's biggest enemy was its own system. What actually happened? Combining Japanese and American sources, Allied technical intelligence, and post-war engineering analysis, here's the reality. Japan entered World War II with aircraft industry adequate for limited conflict, but fundamentally incapable of sustaining protracted modern warfare. Critical vulnerabilities, resource dependence, no domestic aluminum, minimal steel production capacity, inadequate industrial infrastructure. 2. Technological limitations, designs borrowed from Western sources, adapted rather than innovated, always playing catch-up rather than leading. 3. Quality control philosophy. Emphasis on craftsmanship over standardization. Skilled individual work rather than efficient mass production. This worked for boutique production but couldn't scale. 4. Inter-service rivalry. Army and Navy operating independent supply chains, refusing cooperation, actually sabotaging each other's efforts at times. 5. Cultural inability to acknowledge failure. Hierarchical structure preventing honest upward communication. Bad news suppressed until crises became catastrophic. 6. Training system collapse. Slow pipeline training adequate for peace, but unable to expand quickly. Pressure for numbers led to quality degradation. None of these vulnerabilities resulted from Allied actions. All were recognized by Japanese technical experts. All were ignored by military planners. Allied strategic bombing accelerated the collapse and ensured it couldn't be reversed. But collapse was coming regardless. The counterfactual question historians sometimes ask, what if Japan hadn't been bombed? Could internal improvements have stabilized aircraft production? Available evidence suggests no. By mid-1944, the material pipeline was empty. No bombing campaign caused the aluminum shortage that resulted from submarine warfare, and Japan's inability to protect sea lanes. Engine quality problems stemmed from alloy shortages, themselves caused by blockade rather than bombing. Pilot training degradation resulted from fuel shortages, again due to submarine warfare. Even without a single bomb falling on Japanese factories, production would have declined through 1945 as materials ran out and quality deteriorated. Bombing ensured the decline was steep and irreversible. It destroyed physical plants and forced disastrous dispersal, but it accelerated an existing trajectory rather than creating one. Modern parallels. This story resonates because the underlying pattern, institutional dysfunction masked by blaming individuals, remains contemporary. Consider any modern organizational failure. Financial scandals, technological disasters, military failures. Common thread. Leadership making systematically flawed decisions, ignoring expert warnings, then scapegoating lower-level personnel when consequences arrive. Japan's wooden fighter program exemplifies this pattern perfectly. Experts identified problems early, 1938 resource assessments, leadership ignored warnings, pursuing aggressive expansion regardless, system adapted superficially without fixing root causes, wooden aircraft without addressing training, quality control, logistics, individuals blamed rather than systems examined, pilots accused of lacking fighting spirit. The specific context was unique. Total war, Imperial Japan, 1940s technology, but the organizational pathology is timeless. The question of responsibility, who deserves blame for the unnecessary deaths of pilots like Lieutenant Tanaka? The easy answer, everyone. Shared collective responsibility. The accurate answer, primarily those with authority and decision-making power who ignored warnings, suppressed information, and perpetuated dysfunctional systems. Engineers who designed defective aircraft? No. They advocated for better solutions and were overruled. Factory workers who produced substandard components? No. They lacked training, materials, and support. Maintenance crews who couldn't keep aircraft flying? No. They worked miracles with impossible resources. Pilots who died in failing aircraft? Absolutely not. They were victims, not perpetrators. Responsibility belongs to military leadership who launched unsustainable war, procurement officials who prioritized production numbers over reality, and commanders who blamed subordinates rather than acknowledge systemic failure. The tragedy of Lieutenant Tanaka and thousands like him. They paid the price for decisions made years before they ever climbed into cockpits. The 3K-106 prototypes at Fusa Airfield survived the war intact. American technical intelligence teams examined them carefully in September 1945. Engineers from Wright Field conducted structural tests, destructive testing of bonded joints, and performance evaluations using the partially damaged first prototype. Their assessment, filed in Classified Technical Report T2 1945127, concluded, Japanese wooden fighter construction demonstrates adequate engineering but insufficient development, airframe weight excessive, performance marginal, operational reliability uncertain. Design represents desperation rather than innovation. The prototypes were photographed extensively, then scrapped. Wooden components were burned, metal parts, engines, landing gear, instruments were salvaged for analysis or disposed of. By 1946, no physical evidence of the key 106 remained except photographs in American archives and design documents in Japanese ministry files. The men involved scattered to post-war lives. Nakamura Takeshi, the project engineer, found work with Toyota Motor Corporation's fledgling automotive division. His experience designing wooden aircraft proved oddly relevant to post-war material shortages in automobile manufacturing. He never publicly discussed the key 106. Test pilot Lieutenant Yamamoto survived the war, returned to his family's farming village in Nagano Prefecture, and reportedly never flew again. General Endo Saburo, Chief of Air Ordnance Bureau, testified to American investigators, then faded into obscurity. He died in 1962. His obituary made no mention of wartime service. Staff Sergeant Yoshida Kenji, the mechanic who'd kept private lists of pilots killed by defective aircraft, became a taxi driver in Osaka. In 1979, he participated in an oral history project, the only time he discussed wartime experiences publicly. Lieutenant Tanaka Hideki and thousands like him remained dead, their names inscribed at Yasukuni Shrine, alongside millions of other war dead. No separate accounting distinguishes pilots killed by mechanical failure from combat deaths. All are honored identically, or dishonored, depending on perspective. What became of Japan's aircraft industry after surrender? Allied occupation authorities initially banned all aviation activity in Japan. The prohibition lasted 7 years. Major aircraft manufacturers dissolved. Nakajima split into multiple companies, eventually becoming Prince Motors and later merging into Nissan. Some engineers formed Fuji Heavy Industries, now Subaru. Mitsubishi survived by diversifying into automobiles, heavy machinery, and shipbuilding. Restarted aircraft production in the 1950s. Kawasaki transitioned to motorcycles and industrial equipment. Tachikawa closed entirely, facilities converted to other uses. When Japan resumed aircraft production in the 1950s, it started fresh, licensing American and European designs, learning modern production methods, building new institutional culture. The wartime industry's failure taught lessons, though whether those lessons were fully learned remains debatable. The Kai 106's legacy extends beyond aviation history into organizational studies. Business schools occasionally use it as case study in institutional failure, how groupthink, hierarchical rigidity, and refusal to acknowledge problems create catastrophic outcomes. Military academies examine it as cautionary tale about logistics, quality control, and honest communication in warfare. Engineering programs analyze it as example of design constraints under extreme resource limitations and why corner-cutting without proper validation kills people. But perhaps most importantly, it stands as reminder of a darker truth. Institutions under stress scapegoat individuals rather than reform systems. This pattern didn't end in 1945. Consider NASA after the Challenger disaster. Initial attempts to blame individual engineers before acknowledging organizational culture problems. Consider financial crisis of 2008. Low-level traders prosecuted while systemic failures in banking regulation largely unaddressed. Consider countless military failures where junior officers face courts martial while senior leadership escapes accountability. The specific circumstances change. The pattern persists. Memory and forgetting today in Japan. The key 106 exists as curiosity for aviation enthusiasts. Model kit manufacturers produce plastic replicas for hobbyists. Wikipedia articles provide basic facts. Aviation museums occasionally feature information panels. But the larger story, institutional betrayal, scapegoating dead pilots, systematic denial of responsibility, remains less discussed. Why? Partly because honest examination requires confronting uncomfortable truths about Japanese wartime conduct and post-war narratives. Partly because every nation prefers myths of noble sacrifice to messy realities of institutional dysfunction. Partly because the dead can't speak for themselves, and survivors often chose silence. But primarily because acknowledging systemic failure requires change, and change threatens existing power structures. The Pilots Memorial in 1982, a group of Kisame, 84 pilots who survived the war, established a small memorial at Fusa Airfield's former location, now occupied by Yokota Air Base. The monument's inscription reads, "In memory of comrades who flew in difficult circumstances and did not return. May their sacrifice teach future generations the true cost of war." Notably, it doesn't mention mechanical failures, defective aircraft, or institutional failures. The phrase "difficult circumstances" does considerable diplomatic work. One veteran involved in creating the memorial later explained, "We knew the truth, but monuments aren't for speaking uncomfortable facts. They're for honoring dead friends." The full story belongs elsewhere. Perhaps in documentaries like this one. What should we take from this story? First, resource limitations don't excuse institutional dishonesty. Japan faced genuine material crisis by 1944. That's historical fact. But that crisis resulted from decisions made years earlier, and those decisions were made despite warnings from experts who understood the limitations. When you gamble recklessly and lose, you don't get to blame the cards. Second, organizational culture matters more than individual heroism. Japanese pilots demonstrated extraordinary courage, often bordering on suicidal devotion. That courage couldn't overcome defective aircraft, inadequate training, or collapsing logistics. Individual excellence cannot compensate for systemic dysfunction. Third, honesty saves lives. Every warning ignored, every quality control inspector overruled, every pilot evaluation blaming victims instead of acknowledging equipment failures, each represented a missed opportunity to prevent deaths. The institutional impulse to suppress bad news kills people. Fourth, accountability must flow upward. Junior personnel, pilots, mechanics, factory workers bore consequences for failures created by strategic leadership. Those who made catastrophic decisions largely escaped responsibility. This inverts justice and perpetuates dysfunction. Finally, memory work matters. The impulse to simplify history into comfortable narratives, noble sacrifice, technological determinism, us versus them, obscures truth and prevents learning. Real history is complicated, uncomfortable, and often unflattering to all sides. What Japan's wooden fighters teach us the key. 106 represents more than failed aircraft program. It symbolizes how institutions under pressure often choose preserving appearance over confronting reality. It demonstrates how hierarchical cultures can systematically silence dissent until crisis becomes catastrophic. It shows how blame flows downward while authority flows upward, creating accountability asymmetry that shields those most responsible. And it reminds us that every technical failure is fundamentally a human failure. Someone made choices, someone ignored warnings, someone prioritized the wrong things. The wooden fighters were built from sawdust and desperation. They flew, they failed, predictably. But the real failure wasn't engineering, it was institutional courage. The courage to admit mistakes, acknowledge limitations, and tell truth even when truth threatens power. That failure continues today, in different forms, different institutions, which is why this 80-year-old story about Japanese wooden fighters remains urgently relevant. The next time you hear organizational leadership blame individual failures while avoiding systemic examination, remember Lieutenant Tanaka Hideki. Remember the test pilot whose wooden wing peeled away because engineers' warnings were ignored. Remember the mechanic who kept private lists of pilots killed by defects he'd identified. Remember the institutional betrayal that turns victims into scapegoats. History doesn't repeat exactly, but patterns do. Recognizing those patterns requires understanding stories like this one, uncomfortable, complicated, and essential. Thanks for watching. If you found this story compelling, hit like and subscribe for more untold stories from World War II. Which lesser-known WW2 figure or event should I cover next? Let me know in the comments below. And remember, the greatest betrayal isn't losing a war. It's lying about why you lost and blaming those who died fighting.